what an epic intro. I think the last time I heard my full name was when I got into trouble. So hopefully this time around I'm not in trouble. But what I'd like to share with you today is the journey I've taken into software development. There's a really cool game engine I've recently discovered as well that I'm going to be talking about today. The reason why I want to talk about this is I think that developing games is a fantastic way to get people into programming. So I'm going to share with you my journey into that. We're going to be building a game live on stage, and as Lucky mentioned earlier, the live demos always go great. So I'm looking forward to that. And then it's just to prove that it's actually very simple. And then I want to talk about how we can actually get this into schools and the effect that it can have. So as you heard, my name's Claris. I am a graduate developer at BBD. And by raise of hands, who here was at the mid-year party this year? Okay, cool. So quite a few people. Right, so to everyone who was there, you'd probably remember the comedian. It was quite funny. And one of the things that he really stressed was inflating your job title. So I've decided that I'm going to do just that. So I've written an acronym for graduate developer, and it stands for the following. So graduate developer stands for getting ready as a developer. Help me please, I have no idea what I'm doing, exclamation mark. Now, I'm not necessarily saying this was true of my experience, but it kind of was. But this has been my journey so far. So where did we start? So obviously, there are no flawless stories, so I had to add some regrets to my journey. And you will see why I call them regrets in a minute. So I started out by creating adventure games in Word. Now, to everyone who's old enough, you'll remember that there used to be these books, and by the way, I'm speaking like I'm really old. I'm not, I promise. But there used to be these books that would play out a certain scenario, and you would make a decision based on that, which would have you refer to another page. So I originally started out by writing out these games. They were terrible. Then what I did was I moved on to something a little more interactive. I started building levels out of Lego, and honestly, I'm really surprised that my brother still sees himself related to me after what I put him through in playing these levels. So then I moved on to trying to make games with PowerPoint using hyperlinks. Now, as you may have noticed, I underlined, italicized, and bolded the word tried. There's a good reason for that, and I'll explain to you why. So when I originally started with PowerPoint, I was like, hey, let's make something simple, something basic. Let's make a tic-tac-toe game, right? So what you'll do is you'll have a slide that has a scenario. Whenever you click on one of the squares, it takes you to another slide. So you just have to account for each state of a board. It can't be that many, right? Turns out I wasn't a mathematician back then. So I'm still not a mathematician today. I have no idea what that equation means. I found that online. But what I can tell you is that's a lot of slides. So needless to say, that never happened. So I want to tell you a little bit about what PICO-8 is, and for us to really understand what this engine is and why it's so different, we have to look at the meaning of the word pico. So pico means tiny or little in Spanish. It's also a swear word in Chilean slang, but I'm going to leave that one up for your imagination. And based on that definition, PICO-8 is really a tiny game engine. So why do we use the word tiny when we're referring to it? So the reason why we call it tiny is if you look at their website, you'll see that they boast about harsh limitations. And they're not kidding when they use the word harsh. So the reason for that is we have a 128 by 128 pixel display to work with, which is quite small. We also have a color palette of 16 different colors. There's 4 audio channels with 8-bit blurbs. I don't know what blurbs means. It sounds cool, so I put it in anyway. And then, last but not least, we work on game cartridges, and these are 32 kilobytes in size. So this means that your assets, your music, your art, your game code, everything has to fit on this cartridge. It sounds like you're punishing yourself, but it's actually really cool, and hopefully towards the end of the talk, you'll see why. So these are what the cartridges look like. When you export them, they turn into these PNGs, which is a little bit odd because your game code's on there as well, but it's cool because you can actually print these out, and I've seen people make 3D printed cartridges with the games on it. PICO-8 also has a built-in game player called Splore. the reason why this is cool is as people create games on PICO-8 and they upload it to the website, these automatically appear in the game player, so you get to play everything that everyone else is making. But what's also great about this is you can actually modify these games. So no matter how they were built, you can always go back to the source code, which we'll look at a little bit later. The reason why PICO-8 is really cool is because it runs very well on just about anything. I haven't tried running it on a toaster, but I'm sure that will work as well. So in this case, someone actually built a miniature Game Boy running PICO-8 on a Raspberry Pi Zero. And what's cool about this, you can also boot straight into it, so to make these kind of consoles. And while I'm on the slide, just a reminder, so as Lucky mentioned in the previous talk, and to those who weren't here, there's a stand right next to the bar running PICO-8 on a Raspberry Pi with a game. And what we're going to be doing is that the top 3 scorers by the end of today will be announced, and each person will receive a goodie bag. So they're worth fighting for, trust me. What's cool is you'll also get a chance to try out the fruit controllers for yourself. But I do promise you it's very difficult. It's not easy. So if you're up for the challenge. Right, so now I want to talk a little bit about why I think PICO-8 is important. So there's a quote from devex.com that says that more than 50% of today's jobs require some degree of technology skills. And experts say that this percentage will increase to 77% in the next decade. Now, that's a really large number. And if you look at it, this means that simple jobs such as, well, let me rephrase that. Every job that you can possibly think of, things such as maybe administrators, all these kind of things, they actually involve interfacing with a computer. And this will become more and more common, as Tony mentioned earlier, as we move into industrial age 4. So the reason why I think we should teach people how to program, so here's a few quotes from important people. So the first one is Steve Jobs. He said that everyone should know how to program a computer because it teaches you, number one, how to think. A quote from Stephen Hawking: whether you want to uncover the secrets of the universe or you just want to pursue a career in the 21st century, basic programming is an essential skill to learn. Now, you'll note that he doesn't say if you want to pursue a career in IT or anything, he just says a career. And then last but not least, a quote from Zuckerberg says, my number one piece of advice is that you should learn how to keep people's data private. I'm sorry, he didn't say that. He said that you should learn how to program. Right, so I want to bring it a little bit closer to home before we delve into the really cool live demo, and I promise I'm not going to turn this into a sob story because this is a fun talk. So if you look at some of the statistics, in the first quarter of 2018, the unemployment rate among youth was 38.2% in South Africa. Now, this is both good news and bad news. It's bad news because unemployment's never a good thing, but it's also good news because if you're 34 or younger, you're still classified as youth, so you can have your midlife crisis a little bit later on. So when it comes to programming, tertiary education isn't always a necessity. So some of the best programmers I've spoken to have either not attended university, some of them have even dropped out of high school. Now, disclaimer, I'm not taking responsibility and I'm not suggesting that you drop out, but it's not a necessity to actually land a job in this space. So I also think it's cool because when you're able to program, it's a great way to freelance or to even become an entrepreneur and create a new solution. And I'm sure there was supposed to be one more there, but all right. So the reason why PICO-8 is a cool tool to teach people how to program is because game development is something that appeals to the younger audience. I personally have gotten into software development myself thanks to an interest in developing games. So you're probably asking, well, I mean, this is all good, but how are we actually going to get this into schools, especially in maybe more rural, more poorer areas? Well, as we mentioned earlier, it's great because, number one, it's a low-cost setup. So what I mean by that is that one copy right now, as of a licensing, which might change in the future, can be used throughout an entire educational institution. It also runs on just about anything. So a 200 Rand computer, aka a Raspberry Pi Zero, it runs flawlessly on that. So that'll be a great way to actually get these into schools. So that being said, we're going to move on to the live demo. But before we actually make a game, let's talk about what we're going to be making, why we picked it, and maybe some fundamentals in actually designing it. So I was thinking, while I was preparing the talk, what are we going to make? What are we going to make? And for some odd reason, the first thing that popped into my head was Flappy Bird clone. And then I realized that it's probably a bad idea to put people through the despair of watching another Flappy Bird clone come to life. So instead, opted for a Breakout game. The reason why I went with Breakout is, yeah, it might not necessarily be the most exciting action-packed game, but it teaches a lot of good fundamentals, which would be player interaction, building a small physics system, and then also how to handle multiple entities, which in our case would be the bricks. So as a brief design overview, so I don't know how many people have actually gone and designed a game, or maybe even just made something small. But first of all, for a game to be a game, you're going to need some form of player interaction. So in our case, that will be us moving the bat around. You also need a goal, which in our case will be destroying all the bricks. And then last but not least, there needs to be a challenge, and that would be to not let the ball fall and to not run out of lives. So this is what a basic game loop looks like. So firstly of all, the player is going to be providing input. And then there's going to be logic that's going to act on the game based on the input that the player did provide. Last but not least, we'll be giving them visual feedback, and this will tell them how they did they miss a ball or not. This would be our graphics. And then the loop continues, and the player then acts on this feedback that has been given to him. So with that being said, we're going to move on to the live demo. I wanted to use the original Batman let's get to the Batmobile picture, but unfortunately it was quite low resolution. So what you see in front of you, this is PICO-8. This is what you're greeted with when you start it up. And as you can see, it already immediately has this very retro feel to it, which I think is really cool. So we're going to load up our game. And right now, it doesn't actually do anything. There is a little bit of code there that I'll explain in a minute. So this is what our editor looks like. So this is our code editor, and I think for pretty obvious reasons, we're not going to be using the built-in code editor just to a lack of real estate. Let's see, is this mouse working? There we go. So we also have a sprite editor. So as you can see, we have our color palette up there, which is quite small. So how these sprites work, they're all based on an 8x8 pixel canvas. Some sprites can actually span across multiple ones, and we'll delve into that a little bit later. But one important thing to notice here is that you will see where my cursor is currently at, we have an index. And this changes as we move along our sprites. Important to remember because we'll be using that to actually tell Pico what to draw. There's also a level editor, so maybe you're going to be building a tribute to Final Fantasy or some Super Mario kind of clone. This will be a great tool to use. We're not going to use that because everything that we're going to be doing is going to be handled through the actual code. We also have a, whoops, I was not supposed to do that. We also have a sound editor, so we have a few sounds that has been built. The first one is when the ball collides with the bat. The second one is when the ball collides with a brick. And then last but not least, a sound for when you lose a life. Now I realize that this sounds like a fart, but I've grown fond of the sound. Right, so let's move over to, my bad. Okay, that was not supposed to happen. Give me a second. All right, so let's move over to our code, what we currently have. So first of all, is this large enough, by the way? Is everyone okay with this? Okay, a little bit bigger. Okay, cool. There we go. That's better. Okay, so what do we currently have? Well, first of all, this is Lua. So to anyone who's used Lua before, you'd know that it can sometimes be a little bit painful. But the reason why I think it's a great place to start is because Lua does allow us for some form of object orientation, but it also removes all the complexities of inheritance and all of these kind of things. So what we currently have is we have a player object. So what we have in there is a x and y coordinate. This will be for its horizontal and vertical coordinates. We also have a sprite index, and this is, as we mentioned earlier, that this refers to which sprite we're using. And then last but not least, we have a bounding box. So how this works is maybe we have a sprite that doesn't cover the entire canvas, and the reason why we're using a bounding box is to tell PICO-8 where the edges of the sprite actually is within the canvas. So we also have a ball object, very similar to the player object. The only difference here is that we have two different variables, one for its horizontal and vertical speed. We have a an array of bricks, and this is what we're going to be using to this is what we're going to be using to hold all the instances of these bricks. And then we are also greeted with 3 built-in functions for PICO-8. The first one is init, and as the name suggests, this gets called once we load up our game. We also have an update function, which gets called 60 times in a second. This is where all of our logic will be happening. And then we have a draw function, which is going to be providing visual feedback to the player. So I'm going to grab my notes here. So in our current state, we can run this, but we won't actually see anything. So we're going to head up to our init function, and I'm going to call a snippet of code. So first of all, we want to initialize some variables. We want to tell PICO-8 where the player and the ball should be when it starts up. So we've placed the player in the bottom center of the map and the ball straight in the middle. And then what we also want to do is we want to start populating the draw functions. So right now we can't actually see what's happening because we're not telling PICO-8 to draw it. So we're going to do just that, and I'm going to call a snippet of code. So what we have here is we have the sprite function, which is going to draw a certain sprite, provided an index, a location, and as you may have noticed on the player sprite, there's additional parameters. So what these are for is because our player sprite, or the bat, actually scales across 2 canvases. So we also have a for loop where we're iterating through all of our bricks, and we're drawing them at their respective positions. So with as little code as that, we can head back into PICO-8. We're going to load up the latest version. And if we run this, as you can see, we already have a bat and a ball on the screen. Right, so not much exciting yet. Unfortunately, there's still a bit of a wireframe we have to set up, and we're going to do that now. So when it comes to the bricks, we're going to be using bricks over and over again. So we're going to use a factory method and actually build a factory to generate these. So I'm going to go to the bottom of our code, and I'm going to call another snippet. And what this does is we're taking in 2 parameters, which are coordinates. We're creating a new brick object. We're assigning it a random sprite as well, based on one of the first 4 sprites. This way it's a different color every time you play. And then we're giving it a bounding box, and we're also then adding that brick into our array of bricks. So for the factory to work, we actually need to make use of it. We're going to go back to our init function, and we are now going to call add bricks. Right, so what this is we have a for loop, and all this is going to do is it's going to be placing a brick at each coordinate to fill up the top part of our screen. So if all went well, we can now load up our game once more, and as you can see, we are greeted with a very colorful array of bricks. Also, because we're using random indexes, whenever we run this again, we have different colored bricks. Right, so now we want to give the player some form of interaction with the game, actually. So for that, we're going to go to our update function, and I'm going to call a snippet of code here, and I do apologize about the indentation. There we go. Cool, so the way PICO-8 works when you're reading buttons is it doesn't actually ask for the physical button, so this way we can cater for controllers as well. So if button 0 is pressed, we're going to subtract 2 from the player's horizontal coordinates, so this will move him to the left. If the right-sided button is pressed, we're going to add 2 to his coordinates, and then also at the bottom what we're doing is we are clamping the player's coordinates. This is to prevent him from actually leaving the screen. So before we run this and see it in action, we want to write one last snippet of code, for the step at least. We're going to go down to the bottom of our code, and we have our collision function. So this one is probably my least favorite of all the functions due to the fact that it's a little bit difficult to explain. But we're taking in 2 instances, and we are comparing the left side, right side, top and bottom of their bounding boxes with each other. And I think if there's one thing I've learned in my short time in the programming industry, it's that as developers we refer to this as an algorithm. What that means is that we either don't know what we did or we don't know how to explain it. So we can now, with that snippet of code, head back into PICO-8. I lost my cursor there for a second. We're going to load up our latest version of the game. And when we run this now, as you can see, our player can now move around and he cannot leave the bounds of a map. So that's great. We have some form of player interaction, but we're missing quite a few things still. So now we actually want the ball to behave the way that we want it to. So we're going to head down to the bottom of our code. And this is a rather lengthy one, so I'll quickly run over what we're doing here. So this is going to be the logic for the ball itself. Every time this gets called, which will happen once in our update function, what's going to happen is we're going to modify the ball's x and y coordinates based on its speed. If the ball tries to leave the top of the screen, we will invert its vertical speed to get it to bounce back. Respectively, if it tries to leave the left or the right side of the screen, we're going to be inversing its horizontal speed as well. And then what we're going to be doing is we're going to test for a collision between the ball and the player using our function that we wrote a little bit earlier. And we're just going to invert the ball speed if it does collide. And then what we're going to do with its horizontal speed is we're going to take the middle of the player's bat. We're going to find the difference between the ball and the middle of the bat and then make it angle off in that direction. And this just really gives our player a bit more control over what happens. If it tries to leave the bottom of the screen, we're going to reset it to its original position. And as you may probably be asking yourself now, reset ball, we didn't build that function yet. Yes, you're correct. So let's quickly build that. Otherwise, this will not run. So we're going to call our snippet of code. And all this function really does is we're setting the ball's coordinates back to the center of the screen. And we're giving it a random direction to shoot off from. Now, you may have noticed that this is very similar to what we're doing in the init function. So we're actually going to call this function there instead of our original code, and this is a great way to show that you sometimes need to reuse snippets of code because of the fact that we're working with very limited space. So I'm going to go over to our init function. We're going to call reset ball, and I believe I'm not missing anything, so we can head back into PICO-8. We're going to load up the latest version of our game once more. And when we run this, nothing happens. Live demos, right? So, so the reason why this is happening is we did define the behavior of the ball, but I think we forgot to actually call that function that defines its behavior in the update. So we're going to do that now. And step 1. And as you can see, it now works because we didn't mess it up. There we go. So our ball now collides off the player's bat. And then as you can see, if it leaves the bottom of the screen, we get the sound effect. So that's all good and well. The problem is the ball's actually going through the bricks. And that kind of defeats the purpose of the game. So we're going to write some behavior for the bricks as well. I'm going to head down to the bottom of our code once more. And I'm going to call in another relatively large chunk of code. So what's happening here is, to everyone who's programmed or at least developed games before, you'll know that there's a very, well, I'm not actually sure about all the other methods, but I'm going to use one of the methods that I'm most comfortable with for collisions, which is to actually predict if there's going to be a collision within the next iteration of the game logic. The reason why we're doing this is if you, let's say you're calling your collision function and you're checking if there's collision between a brick and the ball, by the time it returns true, your ball is probably on top of a brick, and that makes it a little bit difficult to see which angle it originally hit from. So what we're going to be doing is we are going to create a new object, and this is unfortunately where Lua suffers a little bit because of the lack of inheritance and stuff. But we're going to create a ball predict object. We're going to set its coordinates to what it would be in the next iteration of the game logic. And we're also going to grab the bounding box from our ball. And then what we're going to do is we're going to call our collision function, and we're going to check if it's colliding with a brick. We're going to see if it's currently on the left side, the right side, the top, or the bottom of a brick. And this way we can know where to make it bounce towards. Last but not least, we're also deleting the brick from our array of bricks when it collides with it. And in the same way that we had to call our ball behavior function, we're now going to call brick behavior in our update. So this time around it should work. Right, and we are going to run this, and as you can see, we already have collisions and everything. I don't know, is the sound a little loud for this or? Cool. All right, so we have some form of interaction already. Unfortunately, we don't really have a goal yet, which would be for the player to rack up as many points as possible. And we also don't have a condition or a challenge on how you can lose. So we're going to build those now. We're going to head up to our initializing function once more. So when the game starts up, we want to set additional variables. The first one will be score, and the next one will be the amount of lives that you currently have. You can change these as you want, but we're going to set them to 2 for now, because it becomes painful to listen to the game over sound that many times. All right, and then to actually modify our score, what we're going to be doing is we're going to head over to our brick behavior function. So as you might recall, when we're deleting our brick on a collision, it's best to place this code there, and we're going to be adding 1 to the player's score for every brick he deletes. And then we also need to define behavior for the lives. So we're going to go over to our ball behavior function once more. And here where we reset the ball, if it leaves the bottom of the screen, we're going to call a snippet of code. And what this does is it's going to check if we have more than 0 lives left still, then we're going to be subtracting 1 from the lives. Otherwise, we're going to clear the screen, we're going to stop the game and shout at the player, telling him that he either did really bad or really well. So last but not least, we're missing one important part of the code, and that's the fact that we're not actually telling the player visually how he's doing. So we're going to head back to our draw function, and at the bottom, we want to draw out these variables. So what we have here is we're printing out the score of the player at the top right of the screen, and then we're running a for loop where we're drawing a little ball for every life that he still has left. And we should now be able to load up our game. And as you can see, we have score system, we have visual feedback, and if we run out of lives, there we go, that sounds like a fart, but right, and as you can see, now we're telling the player it's game over, and we're giving him his final score. So though it's not the most refined product out there, this is just proof of how quick and easy it can actually be to build a game in PICO-8. So why do I think PICO-8 is a good starting point for software development, or at least for teaching people how to develop software above other engines? Well, it's good because it teaches, number one, object orientation, which is a very important concept. It teaches an understanding of functions, and due to the limited space that we have, it also shows us how we should write our code so that we can actually reuse these functions. It's also very high level. That means you don't have to worry about anything like memory management and all these painful bits. And it has a very small API. So if you head over to their Wikipedia page, you'll see that there's, I think, around about 30 odd functions that basically allows you to build anything you can think of as long as you stick to these constraints. So this way we're not really overwhelming people with quite a large amount of functions and things they have to memorize. What's cool about it as well, as I mentioned earlier, is that all the games that are published, you can actually decompile. So if you play a game and you're like, hey, that's pretty cool, I want to steal that. We don't call it stealing, by the way, it's called GitHub or something. You can actually decompile these, you can learn from them, and the community is quite active, so it's a fantastic place to start. And last but not least, it teaches you how to plan and how to limit your scope. Now, I should have actually emphasized limiting the scope, because I've had an interesting experience in the past. When I originally started, I thought, like, yeah, I want to make games one day. I want to build an MMORPG that uses the entire world as a map. And turns out that I didn't realize back then, we're talking about companies with like thousands of people and millions of dollars later. I didn't have any of the two, by the way. So it's great to teach you how to limit your scope. And I did go to the meme a little bit too quickly, but I want to leave you with a challenge today. Maybe you're going home to your children. Maybe there's someone young in your life that you know that you can influence. And therefore, I encourage you to, why not pick up a copy of PICO-8? By the way, I'm not getting paid for this, I'm just saying. Why not pick up a copy of PICO-8 or any other engine you're familiar with, and maybe teach them how to program and invest in their lives and in their future. So thank you everyone for listening to my talk. Cool, thank you.